There's a trick tucked inside almost every piece of software you've ever used, so simple it barely looks like a trick at all. It's a single reserved value hiding in plain sight inside ordinary data whose only job is to say stop or nothing here. No extra counter, no extra flag, no second variable writing alongside your data. Just one value doing double duty. It's called a sentinel value, and once you know what to look for, you'll start spotting it everywhere in loops, in search functions, in linked lists, in default arguments you've typed 100 times without a second thought. Here's the core question a sentinel answers. When you're reading values one at a time, how does your code know when to stop? You could count everything ahead of time, but that means scanning the data twice before you've even started. You could carry a separate flag variable through the whole loop, but now you're tracking two things instead of one. A sentinel value skips both of those. You pick one value that could never legitimately appear as real data, and its appearance alone means stop. It's not bookkeeping bolted on from outside, it's baked directly into the data stream, so the same loop that reads your data also knows exactly when to quit. So what exactly is a sentinel value, precisely? It's a reserved value used to signal an end, a boundary, or nothing here, kept clearly separate from the real data being processed. Catch is that it only works if that value could never legitimately show up as actual data. Pick well and the trick is elegant. Pick badly and it silently breaks. Python leans on this constantly. A function defined with a default argument of none checks is x_none to figure out whether the caller actually passed something in. None isn't real input here, it's a sentinel meaning nothing was supplied, letting one variable carry both the data and the absence of data. The classic example is loop termination. Picture a stream of ages arriving one at a time, 23, 41, 17, 56, and then -1. A while loop just checks. If the value equals -1, break out immediately, otherwise process it and keep going. -1 works perfectly here for one specific reason: real ages are never negative, so there's zero chance of confusing the terminator with genuine data. No separate length counter, no extra flag variable, just one reserved value doing double duty as both a stop sign and part of the sequence itself. The same idea shows up under different names depending on the language. In C, the function strchr searches a string for a character and returns a pointer to where it found it, or, if the character isn't there, it returns null. Null isn't a valid memory address for real data, so it's completely unambiguous as a not found signal. Python's none plays the identical role for missing or default arguments. Different syntax, same underlying pattern. One reserved, unmistakable value stands in for there's nothing here, so calling code can check for it explicitly instead of guessing at what happened. Sentinels aren't only for loops, they show up inside data structures too. Take a linked list. Every insert and delete has to handle awkward edge cases. Is this the very first node? Is the list currently empty? Naive code ends up special casing each situation separately. Add a sentinel node, a dummy head, or a tail node holding no real data, and those edge cases disappear. Walking the list always looks the same. Keep going until you hit the sentinel. An empty list and a full list get handled by identical code, because the sentinel node makes the boundary explicit instead of implicit. Here's the catch worth remembering. A sentinel only works if it truly can never collide with legitimate data. If -1 were somehow a valid age, or if none were a value someone genuinely wanted to pass in, the whole scheme breaks silently. Real data gets mistaken for the stop signal, or the reverse happens instead. That's exactly why some languages reach for explicit optional types instead, like Rust's option, which separates "here's a value" from "here's nothing" at the type level rather than overloading one shared value to mean both things. Sentinels are simple and fast, but they carry that one sharp edge. Choose the value carefully and the trick just works. Thanks for watching.